Right, time for the solutions for the benchmark 2 review. So this is basically like a review of the entire term. So be able to do all these things, like number 1, graph an example of a function. Well, there's like infinitely many. You just have to make sure it follows a vertical line test, or in other words, each x value corresponds to exactly one y value, which that one does. Graph an example of a non-function. You just have to make sure it backs on itself. You can draw like a zigzag like that, or you can do like a C, or really anything where if you do a vertical line test, it hits more than once, which would mean one x value, such as 2, has different y values, such as 1, 4, and negative 4. Okay, on 3, if you have a function you want to get f of something, you take this number, you put it in for x, and then compute. So you would get 5 times negative 3 squared minus 7. Square it first, so you're going to have 5 times 9 minus 7. 5 times 9 is 45 minus 7 will give you 38. That one's good too. On the next one, you're going to take this 7, put it where the x is, and then compute. Negative 3 to the 7 minus 4 power plus 12. 7 minus 4 is 3. 3 to the third is 27. Negative 27 plus 12 is going to give you negative 15. Moving on to 5, you just have to get the x and y intercepts. X intercepts are these ones. So that's negative 1, 0, 2, 0. And the last one is going to be 3, 0. The y-intercept is right there. There's only one. It's looking like, see, 1, 2, 3, 4. Okay, yeah. That one's at 0, 6. So there's that one. Okay, x and y intercepts on this. Look, let's see, there's one right there. There's an x-intercept. There's a y-intercept. That y-intercept is 0, 2. Our x-intercept is not looking so clear. It's something 0, maybe negative 1.5. Moving on to 7, x is the number of miles you've driven. What's the reasonable domain for x? So domain is like what numbers you put in for it. You can get any number of miles, any like decimal number of miles even, as long as they're positive. It's really, really difficult to drive a negative number of miles, but you can do like 0.7, 0.32 miles, whatever. X is number of people attending college. Reasonable domain. All real numbers is out. Okay, you can't have a half of a person, which would be a real number. Positive rational numbers. Rational numbers are fractions, and real numbers out, again out. And that leaves us with whole numbers. Those are just the counting ones: 0, 1, 2, 3, etc. Okay, the link in the square brackets. Moving on to 9, the table below shows values of the car T after its purchase. Average rate of change from the value of 0 years to 4 years. So we need to get the rise over the run. The run is going to be 4. So whatever we get is going to be over 4. And then we need to go from 25,000 to 10,240. So you take 10,240, you subtract out 25,000. And then divide that all by 4, you'll get your average rate of change, which will give you, when you subtract the top, you're going to get negative 14,760. When you divide by 4, it reduces down to being negative 3,690. Moving on to the next one, you're supposed to find the slope of the secant line from x negative 2 to x3. Well, x negative 2 is right here, and x3 is right here. So you need to get the slope of the line going between those 2 points. Well, you can just count this if you really want to. Like 1, 2, 3, 4, 5, down 5, so that's negative 5. And then going over 1, 2, 3, 4, 5, 5. So your rise over your run, rise 5, run 5, well, rise is negative 5, gives you negative 1. And the next part, x equals negative 3 to x equals 1, which is right there. So the secant line will go right through that. To get your run, you're going 1, 2, 3, 4. The run's 4, so that goes on bottom. The rise is going to be 1, 2, 3, 4, 5, 6, 7, 8. 8 over 4, which is just 2. There you go. Moving on to the next one. You need state all the following characteristics, domain, range, etc. Remember, domain is the possible x values. Well, the graph keeps going left forever and right forever, so your x's can be any old number, and it's all connected, it's all continuous. So you can have that. The range, similarly, from negative infinity to infinity. The intercepts, we got an intercept there, that intercept's looking like 2, 0, the one on the right. The one on the left is looking like 0, negative 3. The intervals of increase, well, this graph's going up everywhere, so it's increasing for all real numbers, from negative infinity to infinity. The interval where it's decreasing, well, that's going to be none. If it's increasing everywhere, it's decreasing nowhere. The positive interval is going to start right here at 2, and it's going to be here on the right side, everywhere to the right. So that's from 2 to infinity. And the intervals where it's negative is before you reach 2, so from negative infinity to 2. And then the right end behavior, you're going to write as x approaches positive infinity, because that's the right end. Your function is going to approach, well, it keeps going up and up and up as you go right, so it's going to approach infinity. As x approaches negative infinity as you go left, forever your function is going to go level. It's going to keep going down and down until it approaches negative 4. And then the asymptote is that same thing that's on the left side there. It's the line y equals negative 4. Moving on to the next part, domain range, all the same stuff. The domains, how far left and right it goes. It goes left forever, it goes right forever, so all real numbers. The range, also going all the way down, all the way up without bound. The intercepts, we have these 3. Again, it's actually looking like a really similar graph here. At negative 1, 0, 2, 0, and 3, 0. There's a comma there. And there's one more, the y-intercept there, which is 0, 5. So quite a few of those. The interval's increasing, that's where it's going up as you go from left to right. Well, it's going up and up and up until you reach this x value, which is 0. So from negative infinity until you reach 0. 0. And there's another one where it picks up right there, which is about 2.5. And then it continues on to the right forever. The intervals of decreasing is between these two x values there. So that's from an x value of 0 until an x value of 2.5. The interval of positive interval, that's everywhere it's above the x-axis, which is from this x value to that one, which is from negative 1 to 2. There's also another one picking up right here on 3 until infinity. The next part, negative interval, that's before you reach negative 1, so from negative infinity to negative 1. And the next interval is going to be this little piece there from 2 to 3. Right end behavior as your x, as the x approaches positive infinity, just keep going right, your function is going to keep going up and up and up and up without stopping, so it goes to positive infinity. And then as your x's approach negative infinity, function keeps going down and down and down without bound, so it goes all the way down to negative infinity. And since it doesn't have any asymptotes, well, since it's going up and down forever without bound, and keeps going right and left forever without bound, it doesn't have an asymptote. We'll do 13, 14. So which one has a greater growth rate? Well, this one's times by 3, times by 3, times by 3, so that's all times by 3 stuff. And then this one is growing, let's see, it goes up 4 and over 4, so it has a slope of 1. Yeah, it's going to be A, because times it by 3 is definitely a much larger slope. Which of the following has a greater rate? Let's see, that's add 5, add 5, add 5. So this one's all add 5. Your slope is 5. This guy here, it's times by 2 over and over and over and over and over again. That's going to have a greater slope. Not necessarily at the beginning, but definitely after you get going a little bit, because when you jump from 16 to 32, that's definitely a much larger jump. And that's going to be our first video, 1 through 14.